everyone, welcome to our channel Knowledge of Friends. Subscribe to our channel and click the bell icon for the latest update. Here today we'll discuss about the principle of programming languages. I told you about it, and this is your class 5. Already we have done your class 4, and this is your unit 2, which is your language properties. And in this class, as in the last class, we had covered up the control statement, as I told you about the branching, looping and a jumping, that we'll discuss in detail in this class. And in branching, as I told you about if else, if and switch, these were used. And for looping, of course, that we have there, they used while, do while, for, which we will use in a detailed here in this class. And jumping, that is your break and your continue and go to, that these statement we'll be discussing here. So first of all, it's a huge request from my side to all the viewers. Please go through with the subscribe button, and please like, share and subscribe our channel so that many and maximum people can get the information at once, and even though you can also enjoy the video as well. Before this class, we had covered up the unit 1. You can get this playlist while subscribing our channel. You go through with the playlist and you will finding out each and every video which we have done here. So in this unit 2, which is your language properties, first we'll discuss about branching and the flow diagram that I had mentioned you in the last class, so that I don't mention here, and we'll just discuss about the detailed as we have switched. So in branching, that is the first part. In a branching, that branching is a procedure of executing a block of statement on the basis of the result of condition, and this is done through the decision making statement. Where in branching, the first part we have is your, that is comes under your if statement. So let's go ahead with the if statement here. In the term of the if statement here, that if statement is a conditional construct that is used for executing a set of statement, and only if a certain condition is true. Syntax of an if statement in C is to be represented as, that is in the form of if, that is your condition, then start with a curly bracket, and statement 1, statement 2, and then of course we'll close the curly bracket. This is how the if statement is used here. And the statement 1 and the 2 will be executed only if the condition is true. Otherwise, the whole block within brackets will be skipped, and execution will continue after if block. And the condition is always enclosed with a pair of parentheses, and that shows the flowchart. Let's go ahead with the flowchart for the simple if logic, and then we'll discuss about the second one, which is if else in your branching here. So let's go ahead with the flow chart. This is your entry. Then we have condition, and if it is condition is true, then execute statement block. If the condition is false, then exit. Okay, so this is a flow chart here. Now we'll talk about the second one, and that we have here is if else statement here. So in the if else statement, if else statement, that if the if statement will execute only the statement inside the curly braces, and when the condition is true, it will do nothing when the condition is false. And if else construct includes a condition, if it is true, that the statement block within if block will be executed, and if the condition is false, the statement block within else will be executed. And syntax of if else statement in C is to be represented as in the following, that is your if condition that is your statement, block 1, else statement, block 2. That is that the figure shows the flow chart of if else logic here, so that we will be drawing here as well. And that is, this is your entry, and then we have conditions. If it is true, then this will be happen. If it is false, then this will be happen. And if both we have, then it will exit. So this on this references when an entry, and then they face the conditions here. If it is true, then they execute statement, block 1, and if it is false, then execute statement, block 2. Now we'll talk about the second one, and branching, that we have here, that the branching has been divided into if else, if, and switch statements here. So which we had discussed about if statement and if else statement here. Now we're going ahead with the second one, which is the looping one. So the second we have is your looping. The first we have is your branching, second is your looping. In a looping, looping is a process of repeating a set of statements until a condition holds true. For example, displaying the table of a number from 1 to 10, that would require a looping statement, and 3 types of looping statements are used to be accomplish this task. Where looping has been divided into 3, which is your while, to while, and for. So first we'll discuss about while loop. In the terms of the while loop here, in most computer programming languages, a while loop is a control flow statement that allows the code to be executed repeatedly based on a given Boolean condition, and the while loop that can be thought of an repeating if statement, and the while construct that consists of a block of code and a condition or expressions as well. So for while loop, that the initialization has been started with. Initialization statement, while test, loop body, next statement, now for that we will be having a figure, that a flow chart here. So for that we'll discuss about it. And this is your looping here, and this is for while loop, and that comes under image. So it's your initialization, this is your test. So here this is your, after this, and then it will move in the form as well. So here we'll go ahead to discuss about it, and that is in the terms of it, what we have to go through with that. This is your initialization. Then if it is tested and the test is true, then body, and body will go to the initialization of the, then, and that this is the loop has been following. And for this is your while loop as well. If it is false, then it will next statement, go to the next statement. Now we'll go ahead to discuss about the another one, and that is your for loop, and that is so in the for loop, that the for loop is also used for controlling the flow of the statement and allows code to be executed repeatedly based on the given boolean conditions, and the syntax is to be as follows, and for that we'll be going ahead with the syntax as well. So in the same case, the syntax we have for expression, that is your expression 1, expression 2, expression 3, and for that we have single statement, or block of statement. Then we'll close the bracket here. So this is for loop condition that has been following, and for that we have a block diagram as well. So let's go ahead with the flowchart as well. So for that same case, we will be having a diagram. This is your initialization, then we have your condition, then we have body, and then we have incrementations, and then it will goes towards the another one. So let's go ahead with the detail of this, and that is this is your initialization, then we have a condition. If condition is true, then body, and then of course incrementation. After that it will go for then again with the condition, and then it follows the path as well, and if it is false, then it will not work, it will exit here. Now we'll talk about the another one, and that is your jumping. This is your third one. First is branching, second is your looping, and third is your jumping. In the jumping case, here that jumping is a procedure of transferring the executions control to a particular point in a program, and this is done through the jumping statement. So the first statement we have in the terms of the jumping here, and that is the go-to statement. Go-to statement. In the terms of go-to statement, that the go-to statement is used to alter the sequence of C program and start execution from a desired statement. And whenever we use go-to statement with a label, so the control jumps backwards or forward and to search the label and execution statement onwards. And the syntax, the general syntax for the go-to statement we have, and that is in the terms of it, that is your go-to label statement 1, statement 2, label, statement, and statement. So this is for the go-to statement here. And in the same case, the second we have under the jumping, we have a break statement. your break statement. In the term of break statement, that will talk about it, and in the break statement, that the break statement is used to terminate the loop, and whenever the break statement is used, that the control comes to the first statement and after the loop body, and that use the break statement to reduce the number of unnecessary executions of a loop, and this way it speeds up the program execution as well. Third one, under the coming jumping, we have here the continue statement. In the terms of the continue statement, that in some specific programming problems, we need to skip the remaining statements in the loop body and take control of the beginning of the loop, and in the situation like that, continue statement is used here. So now we'll go ahead with the further one, and that what we have to discuss about the another topic, which is what do you mean by a subprogram control, and that is in the detail we'll discuss here. So let's go ahead to discuss about it, and that is the subprogram control. In the subprogram control here, in most of the programs, a simple stack structure is sufficient for managing the storage for the executing program, and each new procedure requires a new block of storage that is containing the local variables for the procedure that to be added on a stack, and existing from a procedure is accomplished by popping that block off the stack. And however, a more dynamic storage mechanism is also needed in C using a function malloc, C++, Java, and Pascal using the function new, and implicitly in the languages like ML and Libs, and a program that can arbitrarily create a storage for a new data objects in such instance that the program needs a heap storage, and which dynamically allocates and frees a block of storage on demand, and that is on in such instance that the program needs a heap storage which dynamically allocates free blocks of storage on demand as well. And a simple subprogram calls return, and a program is composed of a single main program, and which during the execution may call the various subprogram, which is in the turn may each call other subprogram as well, and so forth. And to any depth, each subprogram at some point is expected to terminate its execution and return control to the program that called it, and during the execution of the subprogram as well. In the same case, for the further one, and that will deal with the executions of the calling program is temporarily halted, and when execution of the subprogram is completed, the execution of the calling program that resumes at the point immediately following the call of the subprogram, and this control the structures is often explained by the copy rule, and the effect of the subprogram call statement is the same as would be obtained if the call statement were replaced by a copy of the body and of a subprogram with a suitable substitution for the parameter and conflicting identifiers before execution. The view to this way that the subprogram that call may be considered as control structure that simply make it unnecessary to copy a large number of identicals or a nearly identicals statement that occur in more than one place in a program as well. Now we will go ahead with another one, and that is to be discussed here, and that is of 10 marks, and the question is explain the implementations of call return subprogram. So let's go ahead to discuss about it. Implementation of call return subprogram. Implementation of call return subprogram, that what we have to discuss here. And to understand the implementation of a simple call return control structure, it is important to build a more complete model of what it means to say that the program is being executed. And for expression and statement sequence, we think of each of it represented by a block of executable code at a runtime, and the execution of the expressions or the statement sequence, that means the simply execution of the code, and using a hardware or a software interpreter, the for subprogram we need more. That is the first, that there is a distinctions between a subprogram definition and a subprogram activation. The definition is what we see in written program and which is translated into a template. Activation is created each time a subprogram is called, using a template created from a definition as well. In the same case, if I'm talking about with the second thing, that is the activation is implemented as a two parts and a code segment containing the executable code and constants, and an activation record containing the local data parameters and the various other data items as well. In the same case, that the code segment is an invariant during the execution, and it is created by a translator and stored statically in a memory during execution, and it is used but never modified. Each activation of the program uses the same code segment, and that the activation record is created anew each time that the subprogram is called, and it is destroyed when the subprogram returns. And while the subprogram is executing, the contents of the activation record that are constantly changing as assignment and are meant to be local variables and the other data objects as well. And thus, to keep track of the point at which a program is being executed, we need two pointers. The first is here the current instruction pointer, and the second is the current environment pointer. So let's discuss about it. First we have current instruction pointer. In the current instruction pointer, that the statements and the expression is a subprogram that are represented by the instructions of some sort in an executable code produced by a translator and stored in the code segment. And we consider that at any point during the execution, there is some instructions in some code segment that is currently being or just about to be executed by the hardware or software interpreter. This instruction is termed the current instruction, and the pointer to be maintained in the variable that called the current instruction pointer, and that is CIP as well. That is the current instruction pointer, and that the interpreter act by fetching the instruction designed by the CIP, which is current instruction pointer, updating the current instruction pointer to point the next instructions in sequence, and then executing the instructions which may change the current instruction pointer again to affect a jump to some other instruction as well. Talking about the second one, we have is your current environment pointer. In the current environment pointer, talking about it, we are that because all the activations of the same subprogram uses the same code segment, and it is not enough to simplify to the known the current instruction that being executed, and a pointer to the activations record being used is also needed. For example, when the instructions in the code references a variable x, that variable ordinarily is represented in the activation record. Each activation record for the subprogram has a different data objects named x, and the activation record that that represents a referencing environment of the subprogram. So as the pointer to an activation record that the current referencing environment is maintained during the execution in the variable, we term the current environment point, that is your CEP, and current environment point as well. Let's go ahead with another one, that is write a short note on a recursive subprogram implementation, which has been asked for 5 marks here. Recursive subprogram implementation. In this, talking about that recursion in the form of the recursive subprogram calls is one of the most important sequence control structures in programming, and that many algorithms are most naturally represented using the recursion. And the USP that where the list structures are primary data structures available as well. In the same case, for that, if I'm talking about in a detail. So that for that structures that the recursion is a primary control mechanism for the repeating the sequence of the statement and replacing the iterations of most of the other languages as well. Talking about the specification of recursive call. Specification of recursive calls. So in specification of recursive calls, if I'm talking about here, in the same case that if we allow the recursive subprogram calls or a subprogram A that may call any other subprogram including A, and a subprogram B that calls A, and so on. So syntactically in writing the program, that the probably nothing changes because the recursive program calls looks the same as any other subprogram calls. And in concept there is no difficulty, provide that the distinctions between a subprogram definition and an activation is clear. The only difference between a recursive call and an ordinary call is that the recursive call creates a second activation of the subprogram during the lifetime of the first activation. And if the second activation leads to another recursive call, then three activations may exist simultaneously, and so on. In general, if the execution of the program results in a chain of a first call of subprogram A that is followed by K on the recursive call that occurs before any return is made, and then K plus 1 activations of A will exist at a point and just before return from the kth recursive call. The only new element introduced by the recursion is the multiple activation of the same program that all exist simultaneously at some point during the execution as well. Talking about the specification of recursive call, now we'll go ahead with the discussion about the implementation of recursive call. In the implementations of recursive call, if I'm talking about here in a detail, that because of the possibility of the multiple activations, we need both the CIP and CEP pointers that we had discussed here, and at the time of each subprogram call, a new activation record is created and which is subsequently destroyed upon returned, and a new activation record is created as well for a unique subprogram A and B. And within, if I'm talking about within A, that we could have just as easily created a new activation record for A as a one for B, and in case where A calls B, the lifetimes cannot overlaps, and for any two activations of A and S, that the lifetime of the A completely includes that of B. And the simplifier says that if instead of A calling B, A called itself recursively, the same property would be true, and the new activation record for A that could just be added to the stack containing the older activation record of A. And in some languages such as that is your BLI, and that is your subprogram that called recursively must be tagged recursively, and as the part of the subprogram definitions like C and Pascal, the recursive structure is always assumed here. Now we'll go ahead with the discussion about what do you mean by the static and dynamic scope of variable. In the static and dynamic scope of variables here, in the static and a dynamic scope of variables, the scopes in the textual region of the program in which that that the binding is active, and a programming languages implement the two types of that scoping rules here, as I had mentioned to you about, that is the static scope and the dynamic scope. In the terms of the static scope here, that in this the active bindings are determined using the text of the program, and the determinations of the scope that can be used by the compiler, and the compiler that can determine when binding will be created and destroyed as well. It is based on the program text, and to connect a name references to a variable, compiler that must be find the declarations and enclosing the static scopes, which are called its static ancestors, and the nearest static ancestors is called static parent as well. Talking about the dynamic scope here, in this the active binding are determined by a flow of executions at runtime, that is the call sequence, and the determinations of the scope that cannot be made by the compiler. The dynamic scope that rules are usually encountered in an interpreted language. That binding cannot always be resolved by examining the program, that because they are dependent on calling sequence, and that is based on calling sequence of the program units, not their textual layout, even though that the references to a variable which are connected to the declaration by searching back through the chain of the subprogram calls, and that forced execution to this point as well. Now we'll go ahead to discuss about it, that is your show the storage for local variables. In the terms of the storage for the local variables here, where a block in C is a grouping of declaration and statement, except that a block cannot contain the procedural declaration, where variable declared within a block are local to an execution of a block, and variable C is a local of the following block as well, where we talk about it in this form as well, that is int C, then and of course closing. This just comes under in it, where in this the conceptually the C is bound to a location when a control enters the block, and there is no further use of the location when control leaves the block, and the last in the first outflow of the control through the block simplifies that the block that could be implemented by setting on a stack that is setting up a stack, a frame for each block. The frame is allocated upon the block entry, and a frame is deallocated upon a block entry as well, and where in the same case in the C compiler, so however that tends to treat the procedure activations as the unit for storage allocation, and that is the block that can be implemented by resolving storage for their local variables in the stack frame of the procedure in which they appear here, where in the C compilers, and however that tends to treat the procedure activation as the unit for the storage allocation, that is that block that can be implemented by reserving the storage for their local variables in stack frame of the procedure in which they appear. So the variables in this joins block within a procedure call that can share the storage because they are not needed simultaneously, and that the declarations of ing in the following pseudocode that can share the storage since their scope do not overlap. So for that we will be going ahead here, and that we'll have to write it down as well. Int C, then we have int I, and then of course the code, then we have int j, and then of course we have closed the curly bracket here. Now we'll discuss about the another one, and that is your what you mean by a referencing environment for controlling the data. So let's go ahead with this. So in the referencing the environment for controlling the data explains, so here in this that each program or subprogram has a set of identifier association available for use in the referencing during its execution, and the set of an identifier association is termed that the referencing environment of the subprogram, and the program, that is the referencing environment of a subprogram, is ordinarily invariant during its execution, and it is set up when the subprogram activation is created, and it remains unchanged and during the lifetime of the activation as well, where that the values that content in the various data objects that may change, but the association of the names with data objects that can the subprogram do not, and where the referencing environment of the subprogram that may have several components. So we'll discuss about in a detail here as well. So the first we have here is a local referencing environment, or simply local environment. The local referencing environment, or simply a local environment here, that is set of association that is created on entry to a subprogram that represent the formal parameters and the local variables in a subprogram that defined only within that the subprogram forms the local referencing environment of that activations of the subprogram. And the meaning of the reference to a name in the local environment that may be determined without going outside the program subprogram activation as well. Now we'll go ahead with the detail, and that is the second one, which is non-local referencing environment. Non-local referencing environment. The non-local referencing environment here, that the set of the association for the identifier that may be used within a subprogram, but that are not created on an entry to it. It is termed that the non-local referencing environment of the subprogram as well. So the third we have, which is your global referencing environment. The global referencing environment here, that if the association created at the start of the execution of the main program that are available to be used in the subprogram, then these association forms the global referencing environment of that subprogram, and the global environment is a part of the non-local environment as well. So let's go ahead with the fourth one, which is your predefined referencing environment. So in this predefined referencing environment here, which is that some identifiers that have a predefined association that is defined directly in the language definition, and any program or a subprogram that may use these association without explicitly creating them as well. Let's go ahead with another one, that is what you mean by the parameter transmission and an actual and a formal parameter. So let's go ahead to discuss about it. Parameter transmission and actual and formal parameters. So in this, data objects that is strictly local is used for the operations only within a single local referencing environment. Example, like within a single subprogram. The data objects, however, are often shared among several subprograms, so that the operations in each of the subprogram that may use the data, and a data object that may be transmitted as an explicit parameter between the subprogram, but there are the numerous occasions in which the use of explicit parameter is the cumbersome. And for example, that consider a set of subprogram that all make use of the common table of data, and each subprogram needs access to the table, and yet transmitting the table as an explicit parameter each time, and it is needed in delicious that such that sharing such data sharing is usually based on the sharing of identifier association, and if the subprogram PQR all need access to the same variable x, then it is inappropriate to simply allow the identifier x to have a same association in each subprogram. The association of x that becomes a part of the local environment for one of the subprogram, and it becomes a common part of the non-local environment of all the others as well. And sharing of the data objects through non-local environment is an important alternative to the use of the direct sharing through parameter transmission. And explicitly, the transmitted parameters and results are the major alternative method for sharing data objects among subprogram, and in contrast to the use of the non-local referencing environment, where the sharing is achieved by making certain non-local names visible to the subprogram data objects that are transmitted as parameter, and results are transmitted without a name attached. And in the receiving subprogram, each data object is given a new local name through which it may be referenced. And the sharing of the data through the parameter is most useful when a subprogram is to be given a different data to the process each time, and it is called sharing through a non-local environment is more appropriate, where the same data objects that are used on each call. And a formal parameter is a parameter, a particular kind of a local data objects within a subprogram that the subprogram definitions ordinarily list the name and the declarations for the formal parameter as part of the specification part, like heading. And a formal parameter, that name is the simple identifier, and that the declaration ordinarily local variable declaration. For example, that the C procedure is healing, that is heading, that is a sub index, and char y, that is a character b as well. That defines the two formal parameter, that is named as x and y, and that declares the type of each. And the declaration of the formal parameter, however, does not mean that the same thing as the declaration for the variable and the formal parameters. That is, depending on the parameter transmission mechanism, may be an alias to the actual parameter and the data objects, or that may simply contained in the reference towards it, which is simply contained a copy of the value of that data objects. And any actual parameter is a set of an object that is shared with the caller subprogram, and an actual parameter that may be a local data objects that belonging to the caller, and it may be a formal parameter of the caller, and it may be a non-local data objects visible and that to the caller, or it may be a result returned by a functions that invoked by a caller and immediately transmitted to the caller that called subprogram, where the actual parameter is represented by at the point of call the subprogram by an expression that is termed an actual parameter expression, that ordinarily has the same form as any other expression in the language as well. Now we'll discuss the various methods for parameter passing, and write note on call by reference method as well. So call by reference, call by name, call by value, call by value results, these comes under the various methods of the parameter passing. So that we'll discuss here. Various methods for parameter passing. In the various method for parameter passing here, that is, when a subprogram transfer control to the another subprogram, there must be an association of the actual parameter of the calling subprogram with the formal parameter of the called program, and that the two approaches often use that the actual parameter may be evaluated and that value passed to the formal parameter, or the actual data objects that may be passed to the formal parameter. We describe this by the two steps following process, that is, to describe the implementation detail of the parameter transmission mechanism, that to describe the semantics of how the parameters will be used. So the several methods have generally been devised for passing actual parameter as formal parameter. The first four that are described as the most common, which is your call by name, call by reference, call by value, and call by value result. So that we'll talk about in a detail here. So first we'll go ahead with call by name. In the call by name here, that this model of the parameter transmission where you subprogram call as a substitution for the entire body of the subprogram. With this interpretations, each formal parameter stands for the actual evaluation of a particular actual parameter. Just as if the actual substitutions were made, each reference to the formal parameter requires the re-evaluations of the corresponding actual parameters as well. The second we have is your call by reference. And the call by reference, talking about with the call by reference is here. In this, that call by reference is perhaps the most common parameter transmission mechanism. To transmit a data object as a call by reference parameter means that a pointer to a location of a data object, that is your its L value, and that is made available to a subprogram, and the data object that does not change positions in memory at the beginning of the execution of the subprogram. That I values of the actual parameter are used to initialize the local storage, and that the location of the formal parameter as well. The third we have here is your call by value. In the terms of the call by value, if the parameter is transmitted by a value, the value, that is the R value of the actual parameter, is passed and to the called a formal parameter. The implementation mechanism is similar to the call by reference model, and except that on invoking a subprogram and a call by reference parameter passes its I value, where a call by value parameter passes its R value. Let's go ahead with another one. This is the last one, that is a call by value result. In the call by value result here, if the parameter is transmitted by the value result, that the formal parameter is a local variable, that is your data object of the same data type as an actual parameter, where that the value, that is your R value of the actual parameter, is copied into the formal parameter data object at a time of call, or so that the effect is the same as if the explicit assignments of actual parameters to the formal parameter were executed here. Now we will go ahead with this, and that is the another one which we have your call by constant value. Is your call by constant value. And the call by constant value here, if a parameter is transmitted by a constant value, then no change in the value of the formal parameter is allowed, and during the program execution, that is no assignment of a new value or the other modifications of the value of the parameter is allowed, and the formal parameters that may not be transmitted to the another subprogram except as a constant value parameter, and that the formal parameter does act as a local constant during the execution of the subprogram as well. Talking about the sixth one, which is your call by result. In the term of the call by result here, that is your parameter that is transmitted by a result and used only to transmit a result that is back from the subprogram, and the initial value of the actual parameters a data object that make no differences and that cannot be used by the subprogram, and that the formal parameter is also is a local variable which is your data object, and with no initial value or with the usual initialization that is provided by the local variables, and when the subprogram terminates, the final value of the formal parameter is assigned as the new value of the actual parameter, just as in call by value result as well. In the same case, now we'll talk about working of coroutines here. So these were the six parameters, the methods that for parameter passing using. So here we'll talk about the working of coroutines. So in the working of coroutines here, that term task, and in this, then when a coroutine receives controls from the another subprogram, it executes partially and then is suspended when it returns control. At a later point, that the calling program may resume executions of coroutine from the point at which execution was previously suspended. And if A calls subprogram B as a coroutine, so B executes a while and returns control to A, and just as an ordinary subprogram would do. When A again passes control to B by a resource B, and that B again executes a while and return control to A just as an ordinary subprograms, and thus B appears as an ordinary subprogram. And however that the situation is similar when viewed from subprogram B, and where B is the middle of the execution, that resumes the executions of A as well, where A executes while and return control to B, and that B continues execution and return control to A as well, where A executes a while and return control to B from subprogram B, that A appears much like an ordinary subprogram, and that the name coroutines derives from the symmetry. Rather than having a parent child or a caller, that is your calls here relationship that between the two subprogram, and that the two program appears more as equal subprogram swapping control back and forth as each executes, and with neither clearly controlling the other, as to be shown that in the form of that it will shown as this is your coroutine A, this is coroutine B. So here we have resume B, resume B, resume B. And where it is your, this is resume A, resume A, and of course that is your resume A, resume C, sorry. Then we have resume C, and this is goes on. So these are connected to one another, which is connected here, and from here it is connected to this, then from here it is connected to this, then from here it is connected to this, and from here that is connected to this as well. So this is a control transfer between coroutines, where the coroutines are not currently a common control structures in programming languages outside of the discrete simulations languages, and however they provide a control structures in many algorithms that is more natural than the ordinary subprogram hierarchy, and where at the moreover that the simple coroutine structures that may be readily simulated in many languages using the go-to statement and the resume point variable, that is specifying the label of the statement and at which the execution is to resume as well. Let's go ahead with the question here, that is we have write a recursive formulation for determining if a number n is prime can use any functional language to write this function using your answer, show, evaluation, step for n equals to 15. So this has been asked of 10 marks. Let's go ahead with the solution here. So that solution we have here, that is in the terms of it, and that what we have to go through with that as well. So for that, the solution of a question is your int is prime, your int n comma int x, and if x is equals to n, then return 1, else if n% x equals to 0, then return 0, and else prime, then n x plus plus. So we need C language for the recursive function formulations of a prime number. So assumptions is that for calling this function x, there should always be 2 evaluation steps for the n equals to 15. So for n equals to 15, x equals to 2, that the function will call again for x equals to 3. And in n equals to 15 and x equals to 3, that is second, if the condition n% x that is equals to 0, that will be true for n equals to 15, and x equals to 3 if it returns 0. So it will show 15 is not a prime number here. In the same case, now we'll go ahead with the question, the another question we have, and that is, consider the following program, and that is the program main. Let's go ahead with the program main. Program main, that is so bad, y is your integer, and for that same sake, going ahead, and that is your procedure p x integer begin x equals to x plus 1, write x comma y, end, then begin y equals to 1, p of y, write y, then end. So give the numbers that is printed in the end if y is transmitted by p using. So we have to give the value for the using, that is the first we have used by value, which has also been asked for 10 marks by value. So here we can separate it, so that we will discuss about it as well. So in the by value case, that x equals to 2, y equals to 1, and so write x comma y, which is 2 comma 1, and write y, that is 1. So the second part is your, that is by reference. In the by reference here, x equals to 2, y equals to 2, write x comma y, that is 2 comma 2, and write y, which is 2 here. So now we'll go ahead with another question, and that what we have to even discuss about it. And the other question is all about what we have to solve it out and the terms of it. So that the question is, suppose that the procedure swap if declared as follows. So let's go ahead with the question here. So that the procedure we have, procedure swap x comma y integer, then procedure f integer var z equals that var z integer begin, that is z equals to x equals to y, return z, and f begin, y equals to f, and swap. And to describe the effect of the procedure called swap, that is your I comma a of I and each of the following parameter using methods here. So in this, that you have two differences by the terms of call by value. So in the terms of the call by value, in the term of call by value here, that as we know that in the case of call by value, there is no change in the caller functions and only the changes are reflected into the callee function. So therefore there will be no change in the caller function, but the value of the callee will be changed, and hence in the case of the call by value, the value will be swapped here, and that is of I and a of I here as well. The second we have here is your, that is call by reference. In the call by references here, so that in the case of call by reference, the value at address will be changed, and therefore that the value caller and callee function will be the same. So here the value of the swap function in the case of the call by reference will be swap, which is a of I, and interchange with a I here as well. In the same case, the third one we have is your call by value result. In the call by value results here, so in this, that as we know that if the parameter is passed as a value result, that the actual parameters are copied to the formal parameter data objects at the time of call, so that the effect is the same as in the explicit assignment of the actual parameter to the formal parameter that were executed, and that during execution of the subprogram, each reference to the formal parameters and that is name is treated to an ordinary differences in the local variable. And as with the call by value, when the subprogram terminates, that the final content of the formal parameter data objects that are copied into the actual parameter data objects, and that is the hence the value of for value results of swap with I and a of I here as well. Let's go ahead with another question here, that is in the terms of it, and that is your another question where we have to consider the following procedures, and that is procedure swap x comma y integer, so that is var t is integer begin t equals to x equals to y, and of course y equals to t here. So and that is suppose I equals to 1, and that is a of 1 equals to 2. So let's go ahead with the supposition, that is your I equals to 1, a of 1 equals to 2, a of 2 equals to 3 here. So giving a proper justification, find out the value. We have to find out the value of I, a of I 1, a of 2, and on completions of the call swap, which is your a comma, which is a of I comma I. So if here x and y are passed by values, so let's go ahead with the question as well. X and y are passed by value. So in the x and y are passed by values here. So if this has been asked for 5 marks. If x and y are passed by values, by the value that a of 1 and a of 2, that will remain the same. So that is I equals to 1 and a of 1 is 2 and a of 2 is 3. So because on the call by value, that the caller function does not have any effect and only passed value are a of I and I here. The second we have is your x is passed by value and y is passed by reference. In this, that if x is passed by value and y is passed by reference, then the value of x will not change, but the value of y will change, and that is the new values of the swap, which is a of I and I, that will be 2, 2 here. So the third one we have, and the last one as well, x and y are passed by reference. In this, in call by reference, the value will be a of I, which is your a of I equals to 1 and I equals to 2 here in this, the third one. So all the questions has been solved, and for the first one I will be writing here, which is I equals to 1 and a of 1 equals to 2 and a of 2 equals to 3 here, and for the first one. And the second one के लिए, that is the value will be in the form of a of I comma I. So here the value is 2 2. So this is what we have to cover up, and we had covered up and we had even though completed this unit, which is your unit 2. And first of all, it's a huge request from my side to all the viewers, please go through with the subscribe button and please like, share and subscribe our channel, so that many and maximum people can get the information at once, and even though you can also enjoy the video as well. In the terms of PPL, that is the principle of programming languages, the unit 1 we had covered up, which is the introduction part. Here we had covered up introduction, the role of the programming languages, why study programming languages towards the higher level languages, programming paradigm, programming environment, language description, syntactic structure, language translation issues, programming languages, syntax, stages in translation, formation and translation model as well. In the unit 2, which is your language properties, which we had covered up in this class, which is your language properties, modeling language properties, elementary data types, encapsulation, inheritance, sequence control, subprogram control as well. Now in the next coming class, we'll start with unit 3, which is your programming paradigm, which is programming paradigm, imperative programming, statement types, procedures, activations, object-oriented programming, where we have to cover up the grouping of the data and the operations, objects-oriented programming, functional programming, that is your elements, programming in a typed languages, programming with a list as well. In unit 4, we have to cover up other programming paradigm, which is another programming paradigm in that logic programming, concurrent programming, network programming, language description and semantic method as well. Then after that, we'll start with unit 5th, and that is your Lambda Calculus, which is Lambda Calculus, introduction to the Lambda Calculus, simple types and subtyping, that what we have to cover up. So first of all, it's a huge request from my side to all the viewers, please go through with the subscribe button and please like, share and subscribe our channel, so that many and maximum people can get the information at once, and even though you can also enjoy the video as well. And you will be provided each and every subject that we are doing it, that is your principle of programming languages, data warehouse, computer graphics, as well as quantitative aptitude, reasoning as well. So let's go ahead, and we have completed the artificial intelligence, so please go through with the playlist and please like, share and subscribe our channel. Thank you, hope you enjoy this video. If you like this video, please give a thumbs up and give a suggestion on the comment box. Please like, share and subscribe our channel. Thank you.